Good morning, guys. Today is January 18, and we are now at the pumping station. Motor, medium voltage motor number 6. So, as you see, we have to redo the terminations they had done days ago, because they have used a low voltage terminating kits, and these power cables should be terminated with high voltage terminating kit like this one. Okay, these are the terminating kits to be used on the ends of the cable, and not let me have this that one, that kit. Okay, this is the one that the other group had done using this low voltage insulation, which is not appropriate for the power cables of this 4160 power cable. So we have to redo the work and put on this terminating kit. Okay, this is the specified terminating kit for that, the appropriate terminating kit for that and for this. So we have to redo it, and to give you some idea on how to terminate high voltage cables, our high voltage terminator from Reliable Power Corporation will demonstrate it for you. Sir Danilo Saino from Reliable Power Corporation, who is our accredited TESDA and experienced high voltage terminator. Okay, and stay tuned, guys, and we will detail a portion of the cable to demonstrate it to you. Okay, and this is how to do it. These are the materials to be used in the termination. The masking tapes with the forced spring. Okay, and the seal insulation. So
insulation, they can stress control jacket.
and guys, to be particular with the name of the materials inside this kit, we have this shrinkable jacket in here, and again this
Stress control.
this is the stress control to be applied somewhere in we will demonstrate it to you, no? So this is for stress control of the XLP cables, and this is the Raychem shrinkable tube. Okay, masking tapes with its fourth spring. Okay, so and this is the expansion shield and the manual. So the length to be cut on the cable is instructed on the manual here. So the length of the cable or insulation to be cut depends if it is an indoor or an outdoor. So we consider this cable to be terminated, and we classified it to be outdoor. So these are the corresponding lengths. The corresponding portion of the insulation to be apportioned with the terminating kit. Okay. It is detailed in here how to do it, but still an experienced high voltage terminator has the feeling, has all the how to seal the power conductor against moisture and against how to seal it against surges or against leakage. So stay tuned, guys, and this is how they do it. We will have a demo on a one cable at length. Okay. So done. So memorize mo na yata yan eh. So it is already in their, it's a second nature for them, guys, the length of the terminations. So that's how they measure as per instruction on the manual. Okay. And our main goal is to seal it against leakage currents, moisture, or other contaminants that may penetrate the inside of the cable. Okay? So dealing with cables, guys, like high voltage or medium voltage cables requires delicate handling. and patience, skills, and of course the experience, because you have a different feeling. You have to feel it, guys. Sometimes the the actual output of the target that we wanted to reach out is the how to prevent contaminants from entering the cable, somehow variable on the skill of the technician doing it, the skill, the education, the experience, everything, guys. We are dealing here with high voltage, and this is not an ordinary job for an electrician. Someone has to do it with the correct education, the correct experience, and the feel. You have to have the feel of with all the experiences that you have encountered. You have to have the feel also. So let's see it, and it is detailed in the manual also, but
Next step, sir.
you have to have that feeling and the knowledge, and you need to oh, what happened? Okay, guys, observe courtesy. Okay, guys. Okay. This is the. I was distracted by the noise outside. Okay. So let's move on and let's focus on how we terminated it. See, the force spring now is being attached. Oh, okay. See, and secondary copper insulation, or the copper shielding, is somehow cut to its length. Okay. The force springs serve as the stopper or the marker for that shielding. Okay. So that is the first spring, guys, that will help in marking or stopping and stripping of the copper shield. Okay. Oh. Okay. So we have to strip the copper shield, the 3 copper shields for each cable, no? So, okay. And we can just demonstrate it to you guys. The one cable will do or is applicable to the rest of the cable, so it would be enough. And this is the kit that they will be using. Okay. So that material then is the sealant,
copper tape.
power tape, okay,
Copper tape for
to seal, to shield it from water shielding.
sir, para hindi siya
Okay.
proper siya.
So that tape will help in not what is this? Okay, that will tighten the copper shielding.
Copper shielding.
Yeah. Okay. So now
Hindi siya nakakalas.
it will not loosen. So that tape will help in tightening the copper shielding. So that's a way, that's our simple adaptation to the demonstration, guys. And even if we are the one doing it, we still have to feel. We need to have the feel, because it's not an ordinary job to protect the cable from contaminants. So the goal here is to prevent contaminants from entering the ends of the cable. Okay, like moisture, water, even humidity, and the surges or the leakage currents coming out from that opening. So we need to shield it, or we need to seal it. And we need to prevent the leakage current from coming out, or the moisture or the other external forces or factors that will be coming in. So these are the two forces we need to contain on the power cable terminations. High voltage terminations, okay? So, to update you guys, we have terminated motor pump number 1, 2, 3, 4, 5, and this one is a redo because the other group terminated it with a low voltage kits. They are using low voltage kits for that, and we do not know that this one is intended for high voltage terminations. So a rework.
Tinira namin yung handle na yun.
So guys, for now, uh, we did it in an appropriate time because it's break time, and to avoid some distractions in our documentation, we do it at some opportune time so that we will not be distracted doing this docu. So just stay tuned, and we will just observe, and we will be updated with some knowledge on the termination. So what we have stripping now is the
Silicon.
semicon insulation part of the XLPE. The semiconductor insulation is after that polyethylene. So from the copper to the polyethylene insulation to the semicon insulation,
Mahasol sa pagkakala.
and see, no ordinary termination. Okay. Okay. So same guys applies to the other two cables. After removing the outer skin, then the copper tape was exposed, and the copper tape was stripped to its length, and now the semicon insulation. So a lot of processes to be performed prior to inserting the shrinkable tube, the Raychem shrinkable tube. Okay, and after inserting the shrinkable tube, that will be blow torch. So heat will be applied on the shrinkable tube. You will see eventually what we'll be doing after the stripping. Okay. So we have already consumed 25 minutes recording this video, guys, and it's not as fast as you might think, It takes time. You have to be patient in doing this job, and considering our target. Our target in termination is to prevent leakage current from going out, because the voltage inside this power cable is 4,160 volts. And we also prevent the external factors like moisture, humidity, any contaminants that might enter into the inside of the cable, the copper, because once the contaminants, it will enter the cable at the ends, it will cause abnormalities, it will cause wrong data reading, and it will cause, if we ignore it, it will cause explosions. Okay? It will cause arcing, sparks, electrical sparks, and that will deteriorate the cable, and it will be to be declared unusable or replaceable. So we want to avoid ourselves from losing the cable, guys. So we are treating the cables just like a baby. Okay? The handling of the cable for high voltage takes a lot of patience, deals a lot of experience and knowledge on handling it. With only qualified technicians should handle it, and because handling is the key to prevent the cable from contaminating from either side, inside factor or outside factors. So both factors, only the high voltage terminator can contain that one. So we leave up to them the care, the handling, the what is this, the solution to provide us with higher reliability and protection of our cables. So now we are past to 28 minutes, and we are now about to insert the lugs. Okay, the terminal lugs, our size is 40 or 100 squared for the size of these power cables. XLP is also 100 squared. So okay, this is the lug for that cable, guys, and it shows 40 American wire gauge, which is equal to 300 to 100 squared. 40. Okay, and this is a long barrel. See, long barrel with one hole. Okay, and let us see if it fits here. Okay, see, oh, So it's almost 0-0, guys. So maybe a little adjustment. This is the standard size, and see, just a little bit of enlarging this hole. See? Okay. Just a matter of a hairline. Just a hairline, guys. So it's manageable. Just a hairline to have it done. And it's good because we do not want to have a play, to have a tolerance. We need to have a zero tolerance for that, so we can fit it with a zero tolerance in that. Okay, so
Dito lang ka termination ng power cable on termination process. Pwede spot check before going process. IR testing.
IR testing.
Yes.
Okay. So for now, we will pause. We will pause and we will inject first the IR testing to have an initial data of this cable as well as its continuity. Okay. We will apply 5,000 volts in 1 minute to get its IR values, and the passing for insulation resistance for the cables should be somehow 100 mega ohms. Okay, 100 mega ohms for the cables or higher. If we can have a data of giga ohms, that would be much better. So we will subject it first for IR, and we can finally put the termination kits, okay? High voltage termination kits. Okay.
Ikaw mo na.
Oh.
Ang hindi ko lang nakasagot ng ano. Yung MVSG substation na ano. Nakalagay dito yun. MVSGA, pati yung MVSGB. Hindi yata ito eh. Paano ba ko, sir?
Ano na yan? Dito lang tayo sa
Panel.
panel side lang. Pero sa MBSD,
Hindi ako.
hindi na. I-counter ko na lang yan. Counter ko na lang.
Balik ko na ako, sir.
Oh, okay. Sige
Hindi
lang.
mo natin mag-vlog eh. Bago ako mag-share, sir eh.
Tuloy lang namin to. To complete the docu for now. We need some demo. Okay. Habol na lang ako, Lloyd. Tapos ito. So this is our IR test instrument.
Mega.
The Megger, yeah, for IR insulation resistance. This is the Megger, guys, and we have already validated it with a calibration certificate. We have used it in the past several days, and the calibration certificate for this instrument is already on file. So no problem on this. Doon ka sa dulo para see guys, even if we are doing the IR test, we have to consider safety because the injected voltage on the IR test will be translated into several voltages at the end of the cable. And somebody must watch and have a caution there. There was a caution tape on the ends, but still it has to be guarded by our qualified personnel to guard the area, testing area. So at this end, we will do here, at this end. Okay. For now, guys, while waiting for the setup, see from the civil team, they are now doing the skim coating, and some of our team also are doing on the cable pulling on the VFD looping side. So additional cable for the loop, which they assume to be one set only, but it should be two sets. They are cabling on the MCC room for now. So that will also take time. Okay. And now, guys, this is the mega tester that we have, and if we look at it closely, the setup would be like this. Okay. Now our maker is set at 5 kV, okay, which is matching with our system voltage. So in 1 minute, we are injecting this much in 1 minute. So we will see how the cable will react. Okay, we will wait until 1 minute how the cable behaves. If it has contaminants inside, that will be indicated in this instrument. Okay, that will be red, that will be diagnosed. If there are contaminants, if there are pinholes. Okay, see, guys. Okay, this the reading shows 150 giga ohms, very high. Okay, good insulation, meaning our passing is only 100 mega ohms, but the reading is in terms of 150 giga ohms, so more than passing, guys. So we go to the next cable, the same process applied. Okay.
gig.
So no variation observed for the moment. No changes ever observed. No no difference in the units. It's still in gigaohms, and after some time now the duration ends with 48 gigaohms on the other cable. Okay, so fast guys, our passing is only 100 mega ohms, but we have gathered giga ohms more than passing. Okay, so that is our last cable. See,
Phase C.
look at the setup.
Like a ground test.
That's shield against the hot wire, and its shielding, ground shielding. So that's the setup, guys. That will determine, the setup will determine if the cable is contaminated. Okay, so meaning from this setup, an induced 5,000 volts injected into the cable, and in 1 minute, see, we have 116 giga ohms. So all the rest of the cables are perfectly in terms of giga ohms, and it's declared more than passing. So we can finally terminate these cables, discharge. So afterwards, guys, we have to discharge these cables. Okay, see, saan yung jumper mo dan?
Discarding there.
Other testers have an automatic discharge cables,
Yeah.
but this one is not equipped with that, so we have to manually discharge the cable against itself.
Okay na.
Okay na. Okay, see, we will discharge it, guys, so that even if somebody is touching it, the
Continuation.
current stored, or the static voltage stored in the cables will not cause us electrocution. Okay, so to prove it, guys, I will touch these cables because it has been already discharged to the ground through the body of these scaffolds. So see, I will prove it to you guys that it doesn't have any more static voltage, or it doesn't electrocute me. Okay, see, even if I touch it, guys. But once you are testing the touch, you have to touch it like this, because your reflexes of your hand will be like this, so you can easily remove it. So once you touch any cables, you have to do it like that, not like this, not like that, because your reflex will be like this. So that's the secret in testing the cables by means of your hand. So now the expansion shield are now installed together with the force spring. Okay?
Force spring.
Force spring that will hold and attach the expansion shield to the tape shield, to the copper shield. Okay? And same is true with all the cables. See? That will hold the expansion shield and attach to the copper shield, which provides greater contact also. We have to inform you guys that this expansion shield or the shielding part for grounding should be grounded to our grounding system, one end only. At any ends we have to attach it or connect it to the ground for electrical safety and for discharge of whatever electromagnetic induction occurred or created on the cable. Okay, that's the purpose of having that expansion shield. So the next part is the see, this is the yellow mastic part, guys, that will seal.
Sa silicone.
Then
Silicone, sir.
yes, that will
Shield.
shield the
Silicone.
semicon, which the semicon lacks the property to shield itself from moisture, and having that yellow mastic tape will contain any external force or internal force coming out or external force coming in that will